So, hello everyone. For today problem, we will be solving our stacks new problem, and for its optimal solution, we have to know the previous problem. So, our problem statement is sum of subarray ranges, and I will explain the problem. But previously, you have to understand that you have to know about the sum of subarray minimum and the same for sum array maximum. If you are able to solve both the questions, so you will be able to solve the optimal solution for this question as well. So what our problem says, so our problem says that we have to find the sum of subarray ranges. So firstly we have to find the subarrays, and then for each subarray we will be calculating their largest element and their smallest element, and eventually just taking the difference of largest and smallest we will get another new number, and we will be adding those difference numbers of all the subarrays and returning it as our answer. So this the basic problem statement. For the optimal solution we will be finding firstly the subarray and then calculating their largest and smallest element and just subtracting both. So our pseudocode for brute force will be, we will be taking sum as 0, and our loop will go from 0 to n minus 1 for I, and for j as uh, just take an example to understand the code firstly. Let's take an example 1432 as our given array, and our subarray will be 114 143 1432 443 432 3 3 2 and 2. So for 1, that's our 1 subarray, and its element is 1. So its smallest element is 1 and its largest element is 1. So eventually it will give 0. And for 143, our 1 is the smallest while 4 is the largest. So 4 minus 1, that's 3. So that's how we will able to calculate for all the subarrays. And here we have to notice a thing that a individual subarray means the subarray with a ith value subarray is not contributing anything, so we have to ignore that. So let's come to pseudocode. Our first loop will be run from I equals to 0 till n minus 1. For the second loop, because first element is not contributing or ith element is not contributing anything in itself, so our j loop will run from I plus 1 till n minus 1. And in this we will be firstly calculating the largest, that will be nothing but maximum comma max of largest comma array of j, means we will be traversing through j loop, and I plus 1 to n minus 1 we will be running, and for each subarray we will be calculating their max largest element as the max of largest, that will be initialized as 0 initially, and comma our current element on which we are standing. So similarly for the smallest element, smallest will be minimum of smallest comma array of j, where smallest will be initialized as 0 for the initial value, and even in the end we will be just getting the sum as sum plus largest minus smallest of all the arrays, and in the end we will be returning the sum as our answer. So this is the brute force. For brute force complexity, time complexity will be big O of n square because running of two loops, and space complexity big O of 1. We are not using any extra space. So that's n square complexity is not good. We can optimize it up to n. So for the n complexity, our for the optimal solution, our approach will be to calculate our maximum element and the minimum element. So previously what we have completed sum of sub array minimum, where we are getting the sum of all the elements that are minimum in their current sub array, and eventually adding them and getting a minimum sub array. And similarly for the we have to complete for the maximum, means sum of subarray maximum, where we will be calculating the maximum element which can be in a particular subarray, and that maximum element uh, will be adding means we will be adding every subarray's maximum element and get a number, and after this we just taking the difference of maximum minus minimum and we will be returning that in our answer. So our solution is nothing but just return the sum maximum minus sum of minimum. So we have to calculate the sum of subarray maximum minus sum of subarray minimum and just return that value. That will be our answer. So we have to remember that what we need to for sum of maximum array and sum of minimum array means sub array. So for the sum of means sum of minimum sub array, we have to know about NSE and PSEE, means next smaller element and previous smaller and equal element. So by this we will able to calculate the sum minimum, as we have to get the minimum element, and for the minimum we will be just checking from left side and till right side that we have analyzed this strategy previously yesterday for our previous question, and we will be utilizing same strategy in this question, but there something will be changed. Just we have to calculate firstly NSE and PSEE. By use of this we will be able to calculate sum of minimum subarray, and similarly for the sum of maximum subarray, firstly we will be calculating NGE, means next greater element, and PGEE, means previous greater and equal element. With this we will calculate their left and right, and after that left multiply by right, we will be get the sum minimum. So that the strategy we have discussed earlier, so I will not be discussing that. So that's how we will able to calculate some minimum and some maximum, and in the end just we have to return their difference. So this is the strategy, and for this the time complexity will be big O of 10n, because big O of 5n for our sum minimum and big O of 5n for sum maximum we have discussed earlier, and overall that time complexity reaches some big O of 10n, that is approximately to big O of n, and space complexity will be similar as big O of n as big O of 10n, and that's how we will able to solve this question, and I will be solving this question on late code on next day, and until that stay tuned, stay happy, and we will continue our journey, and thanks.